Good morning, students. Welcome back to the SBR online classes. So, as we are working to learn the permutations and combinations, so to study all these things, we came across some concepts, some tools. Okay, so what were those? Those were fundamental principle of counting. In that, we studied multiplication principle, additional principle, and then we studied factorial notation. Is that right, students? So these were the few concepts which we have understood. Now moving further. Okay, so what do you mean by permutation? Right. So we have discussed what permutation is in the first class itself is nothing but arrangement of objects in a definite order. Is that right? So in the same way, so let us define. So a permutation is an arrangement, right? A permutation is an arrangement in a definite order of number of objects taken some or all at a time. A permutation, what is a permutation? A permutation is an arrangement, right? A permutation is an arrangement in a definite order. This is important. In a definite order of a number of objects taken some. Okay, either you take few things or you take all the things given. Okay, so based on this, we shall recall some examples which I have studied in the first class itself. Okay, so those were first one. What was that example? Example one. Find the number of four-letter words. Right. So find the number of four-letter words with or without meaning which can be formed out of the letters. Okay. So we had to form a four-letter word with or without meaning which can be formed out of the letters of the word rose, right? So rose contain, so we had to make a four-letter word out of which letters? The letters of the word rose. So rose had how many letters? Four letters. R O S E, there are four letters, and using these four letters only we have to form or arrange a four-letter word. Right? Is that clear, student? So what we have done here, out of the number of objects, we have taken all at a time. So four letters were given and we had to arrange all the four letters. Is that clear? So next example. Okay. So I'm not into solving it now. We have solved it. It's just the beginning of the a formula. Okay. So now example two. Given four flags. So given four flags of different colors, right? How many different signals can be generated if a signal requires the use of two flags, one below the other? So what is our second question, students? Our second question is four flags are given. Okay, so four flags of different colors are given to us. So what is the task we need to do? How many different signals can be generated if a signal requires the use of two flags, right? So they have given us four flags. Is that right, students? So they have given us four flags. So what is the task or what is the work assigned to us? Arrange two flags, right? So arrange two flags, right? So what we have done here, a permutation is an arrangement in a definite order of a number of objects taken some or all at a time. So in this example, we have taken all the four and arranged, and in the second example, we have taken only some, that is only two we have taken out of four different flags. Okay, so what I am writing here, you observe even during the previous classes. So at times I have written in this manner because I was preparing you for the next formula or the next notation in the permutation. Okay, so now this is one particular formula, right? So these are the total number of objects given and we have to arrange among four places. Okay, so these are the total number of objects given and we have to arrange it among two objects. So arrangement is nothing but permutation, right, students? Now I'll change this to, right, arrangement means permutation. So we denote it by P. So 4P4. So what does it mean? Out of 4, you have to arrange it among four distinct objects only. Now, what do you mean by this arrangement? Right? 4P2. So 4 flags are given. You have to arrange among 2. Right? You have to form a 2 flags out of 4. Right? You have to form a 4-letter word out of 4. So this gives rise to a basic or a general formula. So what if there are n objects? They have given us n objects. So total objects n. We have to arrange it among r objects. Right? So you have to arrange r things out of n things. Is that clear, students? So this is a general formula. So now we shall see what is NPR is equal to. You have understood what is NPR. So NPR. So it is read it as NPR, or even this formula is used, right, to denote. These are just some, both are same, right, both are same. Okay, in NCERT this notation is used, and in some reference books this symbol is used. Both are same. P means permutation, permutation means arrangement. Is that clear? So arrangement of r things out of n things, right, n distinct objects. Okay, and so this is also same thing. So you need to read it as, okay, arrangement of r things out of n distinct objects. Okay, so now we shall see what is a NPR formula. Okay, so I hope you have understood this. Okay, so the now next statement. Okay, we shall arrive at a general formula. Okay, so to find the number of permutations of n distinct objects. Distinct means all are different. They must be different from one another, not same. This is also very important, students. Keep in mind distinct objects, because there is one more statement where you will understand more clearly. So all n objects are different, taken r at a time, where r is between 0 to n and the objects do not repeat. So this condition is also very important. Okay, so now this the number of permutations of n objects taken r at a time and the objects do not repeat is nothing but NPR, or P of n comma r. Now we shall derive what is a NPR formula. Okay, so as you read here, the number of permutations of n distinct objects. Okay, so there are n distinct objects and you have to arrange r things at a time. Okay, you have to arrange r things out of n objects. Is same as filling. We shall go back to that basic principle, our basic way of solving the problems, right? So they have given n objects. They have given n objects and they are asking us to arrange r things at a time. Okay, so that box method, what we used to do, right? So this is our first box we have. So how many we have to arrange? R, right? So this is our second box. This is our third box. So on up to, right, rth box, right? So to fill this r boxes, to fill this r empty boxes, how many objects we have? How many distinct objects we have? N. And one more condition is the objects do not repeat, right? So let's start with the first one. The first place Okay, so the first box, to fill the first blocks, to fill the first box, how many objects do we have? We have n objects. Is that right, students? So can I say n ways? Right. So to fill the first box, I have n ways. Right. So now next, and I have to fill the second box also. And one more condition is the objects do not repeat. Means out of n objects, one is used here. Now we are for the second box. How many objects we are left with? One less than n. Right. So this is nothing but n minus 1, right? So we are getting reduced now. See, for example, we are given 10, we are given 20 objects and they are asking us to arrange among 10 objects. So, and the condition is the do not repeat, right? So to fill the first box, how many ways we have? 20, right? So it is, you cannot repeat, means one is used here and that particular you cannot use it again in the second, so it will be reduced. So again you are left with how much? 18, right? 17, so on. You are getting reduced, right? So if n objects are there, so to fill the first box, you have n different ways, and the condition is do not repeat. So the second box can be filled in how many ways? N minus 1. And the third box can be filled in how many ways? N minus 2. And I am saying, okay, concentrate students. And means what I have told, multiplication principle. Similarly, if there is a fourth one, there are, because up to R, I cannot write all the boxes here. 1, 2, 3, 4, 5, 6, 7, 8, 10, 100, 1000, 10,000 up to R. There are infinite between. That's why I've added a dot. Okay. So it's understood. So n minus 3, n minus 4. Right. And to fill the rth box, we have n minus of r minus 1 ways. Okay. So to fill the rth box, we have n minus of r minus 1 ways. Okay. You might be wondering how sir has written. Okay. N minus of r minus 1. Okay. So one more thing, if you observe carefully, it is following a particular pattern. Okay. So that pattern is, if you observe, to fill the first box, how many ways do we have? N ways. So can I write this as n minus of 1 minus 1? Right, students? So what is 1 minus 1? 0. N minus 0 is n ways. Right? These two are similar. And to fill this, okay, so this second one, can I write it as n minus of 2 minus 1? Right? So 2 minus 1 is nothing but 1. So n minus 1. Right? So the third one, if you observe, third box, right? So third box, 3 minus 1. Okay. So if you observe the pattern, the first box can be filled in n ways. It is following some sequence. If you observe, it is following some sequence. Right? So this is n minus of 1 minus 1. This is second box is 2 minus 1. Third box is 3 minus 1. So similarly, R box will be R minus 1. Okay, students. So now what we have done, we have filled R boxes using n distinct objects. Okay, so first box we filled, and we filled the second box, and we filled the third box, fourth box, fifth box, so on up to rth box, and keep on saying and means multiplication principle. So what we have done here in this part, what we have done, we have arranged R, or we have filled R empty boxes using n distinct objects. Okay, so we have arranged R things out of n things. So this is nothing but R. What we have done, arrangement of R things out of n. right? And what is that arrangement? N minus 1, n minus 2, n minus of r minus 1. So hence by multiplication principle, hence by multiplication principle, so arrangement of r things out of n things is nothing but n into n minus 1, n minus 2, right? N into n minus 1 into n minus 2, so on up to n minus of r minus 1. Or I can simply write it as, so npr is equal to n into n minus 1, n minus 2, right? So on up to n minus, I'll multiply minus inside, minus r plus 1. So this is your understanding of npr, or you can say this itself is the formula, right? But if you look at the formula, doesn't it look very long, very lengthy, right? It's kind of a tedious thing. Okay, so it looks very awkward. So formulas must be a bit very small. Okay, so npr, if you observe, it's like a very lengthier one. Okay, so let's shorten this or make it more easy using some idea, that is our factorial notation. Is that clear, students? Factorial notation. So this itself is your understanding of npr, but a formula must look very short and sweet, right? But this looks very lengthier, right? This is also right, but in solving problems, every time writing such a huge formula, it will take a lot of time, and it looks a bit awkward, right? So let's make it short and simple. Okay, students. So I have told you how we can use it using the idea of factorial notation. Okay, so now we have got what is NPR. So I'll rub these things so that I'll get some space to derive it. Okay, students. So what is NPR now? We have understood what is NPR. N into n minus 1, n minus 2, so on up to n minus r plus 1. Okay. So now I've told you, let's use factorial notation help. So for example, what is 4 factorial? 4 factorial is nothing but product of first 4 natural numbers. Or I have told you, while solving problems, use it in the descending order. So 4 factorial means start with 4 and then it keeps on reducing till 1. Okay. Now 5 factorial. Okay, 5 factorial. It starts with 5 till it reaches 1, right? Similarly, 6 factorial. 6, 5, 4, 3, 2, 1. Okay, in the descending order. And you can observe one thing also. Okay, 4 factorial starts with 4 and then it reduces by 1. 4 minus 1. Right, 3, and then from here again it reduces by 1. So it's a pattern. What it is following is a difference of 1. Look here also, from 5 reduced by 1, 4, from here to here reduced by 1, 3, right? So even in 6 factorial, so it's nothing but it's following the chain of reduction by 1, right, students? So now this is our NPR. This is our NPR. Okay. So now what I will do, I have to use factorial notation, right? So it has to end till 1. So R box is n minus r plus 1. So reduce it by 1. So n minus r plus 1. Reduce it by 1 means subtract 1. So what happens? 1 minus 1 get cancels, right? So now we are left with n minus r. So the next place will be n minus r. Similarly, the other next place will be reduced by 1, n minus r, reduce it by 1, minus 1. So on up to 3 into 2 into 1. Right? So it will be reduced till the last. Okay. So this just only this much is our NPR. But what I have done is, to make it very short, I have used the factorial notation idea. So I have multiplied it. Sorry. Okay, this is our NPR. Okay, since this was more lengthier, to reduce it to short form, I have told you I am using factorial notation idea, right, students? So from here, reduce it by 1, n minus r, n minus r minus 1, n minus r minus 1, up to 3 into 2 into 1. So this term is multiplied extra, right? And it has to be balanced by dividing. In mathematics, the things must be balanced. Okay, you can't leave as it is. So n minus r minus 1, so on up to 3 into 2 into 1. Okay, students. Okay, now you can see in the denominator, it starts with n. Okay, and it gets ended at 3 into 2 into 1. So this is nothing but our n factorial. Right? So n minus 1, n minus 2, n minus 3, n minus 4, so on up to 3 into 2 into 1. Right? So this is our n factorial. So that's why I've given you an idea. Again recalled 5 factorial, 4 factorial, right? So 4 factorial means it starts with 4 and goes on multiplying till 1. It starts with 5 and it goes on multiplying till 1. Okay. So now look here. In the denominator, it starts with n minus r and goes on up to 3 into 2 into 1. So this is nothing but our n minus r factorial. Okay, so now this is a simple formula to even remember or to use. It looks very short and sweet, right? Rather than the previous lengthier one. So now by this one, memorize it, remember it, NPR. So to arrange R things out of n things, what is the formula? N factorial by n minus R factorial. Is that clear, students? So this is the formula for permutation with the condition. You hope you have not forgotten what I have told. Do not repeat condition. Right? Is that clear? We shall see what happens. What will be the formula if repetition occurs? Okay. So if repetition does not occur, the formula is NPR is equal to n factorial by n minus r factorial. Okay, students. I hope you have understood this. Okay. So we shall see some special cases. Using the permutation formula, we shall see some special cases. And be regular to the class and be regular to the studies also. Permutation and combination is a logical, it depends upon logical thinking, and it requires daily efforts. Either it might be any topic going on, mathematics requires daily working hard. Okay, you need to work hard daily, then only you'll understand things and remember things. Otherwise, if you just open your books during the time of examination, it will scare you. That's why most of the students find mathematics difficult. Okay, but be in touch, students, daily. It will be more easier. Okay, so what is the formula we found for the permutation? NPR is equal to n factorial by n minus r factorial. Okay, you should keep in the bracket. The factorial is for n minus r complete. Some students, what they do, n minus r factorial. Sir, correct already anta. Right? You yourself decide now. Is it correct? This indicates n minus. The factorial is only for r, but this indicates the factorial is for n minus r. Right? So when we give back your test papers, okay, some students think before only you should understand how the representation is. Don't get confused. Okay, so now we shall see some special cases. So first one, what if when r is equal to n? Okay, so what if all the objects are taken? Okay, so you have to arrange n objects out of n objects. Means you are arranging all the n objects. So now replace r by n, n p n. I am just replacing r by n. N p n is equal to n factorial n minus r. What is r here, students? N factorial, right? So n factorial by n minus n, 0 factorial. Okay, so now you already know what is 0 factorial, 1. So which is equal to n factorial. So what is our npn? Npn is equal to n factorial. Remember this also. So what is npn? Permutation, arranging n things out of n things. Right? So what I am saying on the left hand side, arranging n things out of n things. So arrangement I am talking equal to n factorial. Right? If it is equal means the concept has to be similar to the RHS also, right? So if NPN indicates arrangements, then n factorial also indicates arrangement, students. Okay, so now understood, right? So factorial notation is also nothing but a kind of is a tool of arranging things only. So that's why I have told you in the previous 2 classes also, you can arrange only positive things. You cannot arrange negative things, right? So if you have 5 books, you can arrange all the 5 books, or you can arrange all the 4 books, or 3 books, 2 books, 1 book, or 0 book, right? 0 books in the sense you need not arrange. Is that clear, students? But you cannot arrange -2 books, -3 books, -4 books. Now understood? So that's why -4 factorial doesn't make sense, or -3 factorial doesn't make sense, -2 factorial doesn't make sense. So that's why negative factorial. So number of ways, number of possibilities is not defined for negative things. Right? So you can see, if I say you have 5 chocolates with you, okay, or 4 pencils with you, you can understand that thing. But what if I say you have -3 chocolates with you? Right? It doesn't make sense, right? The same way, right? So -4 arrangements, -3 arrangements, it doesn't make sense. Okay, I hope so. This negative concept is also clear. So remember this. This is also one formula only. Npn is equal to n factorial. So 2p2. See, in place of n now it is 2 I have taken. So what it will be? 2 factorial. Right? 3p3. 3 factorial. 100p100 is equal to 100 factorial. Is that clear, students? So this is how you use the formula. So npn is equal to n factorial. Now the second case. So in the first case, what we have done, npn means we have taken all the n distinct objects. So now second one, what if we take, so let me write first, when r is equal to 0. What happens when r is equal to 0? Right? So let us represent it np0. It means arrange 0 objects out of n objects. Right? Arrange 0 objects means you need not arrange anything. right? So n objects they have given you. N objects they have given you. They are asking us to arrange zero objects. Zero objects is nothing. Is in fact nothing, right? So letters we have studied already. Okay, zero factorial. Zero factorial arrangement is one only. So let's see by this formula also whether it is right or no. Right. So n factorial divided by what is r we have taken? 0. N minus 0 factorial. So np0 n factorial by n minus 0 is n factorial. Now if you observe n factorial get cancels. Okay, so number of permutations of zero objects taken, sorry, number of permutations of n objects taken 0 at a time is nothing but 1, or arranging 0 objects out of n objects is nothing but 1. Is that clear? npn, remember this, okay? It will be easier for simplification. You can reduce your time. npn is equal to n factorial, np0 is equal to 1. Okay, and the formula for permutation when objects do not repeat is npr n factorial by n minus r factorial. Okay, so now one more case. So third one, when r is equal to 1. What if happens if we are arranging 1 out of n? So n p, just replace r by 1. Okay, so n factorial by n minus r. What is r? 1 factorial. Is that right, students? So now np1 is equal to, can I write n factorial as n into n minus 1, n minus 2, n minus 3, so on up to 3 into 2 into 1. But I will stop here only, n minus 1 factorial. Because I have told you keep observing at the question, right? So now np1, because in the denominator n minus 1 factorial was there, I have stopped at n minus 1 only. So n minus 1 factorial, n minus 1 factorial get cancels. So np1, if you arrange one thing out of n objects, is equal to n. So you have studied three special cases. npn is equal to n factorial, students. np0 is equal to 1 and np0 is equal to 1 and np1 is equal to n. Okay, so we have understood the formula for npr when repetition is not allowed. So what is the formula? npr, memorize it, students. npr is equal to n factorial by n minus r factorial, and these are some three special cases. Okay. So now we have solved a formula npr when repetition, this is important, when repetition is not allowed. Okay, so now we shall see what happens when repetition is allowed. Okay, they're asking us to repeat all the objects. Okay, so now write down. So what is that? The number of permutations of n distinct objects taken are at a time when repetition is allowed. So we shall see what is the formula for repetition is allowed. Okay. Now, so you have to arrange R out of n objects. You have to arrange R out of n objects. So draw R boxes. first box, second box, third box, fourth box, so on up to R box, right? So how many objects are given, students? N objects are given. So to fill the first box, how many objects do we have? N. And the condition is you can repeat them. You can repeat them. So that means for the second box, again have N. For the third box, and again I have N. I am also saying and we have to fill up to R, right? So N, so up to R boxes you can repeat them, and every box can be filled in N different ways, right, students? Now look here. So if we consider only two boxes, so what will be the case? N square. If we consider three boxes, it will be n into n cube. If you consider four boxes, it will be n into n square. N square into n cube into n to the power of 4, n to the power of 5, n to the power of 6, n to the power of 7, n to the power of 10. Up to rth box it will be n to the power r. So your formula of NPR, when n distinct objects are given and you have to arrange it among r distinct objects, and one more condition is repetition is allowed. The formula is n to the power r. Okay, so these were some of the formulas. Is that clear? So we have studied or we have derived NPR when digit repetition is not allowed. N factorial by n minus r factorial. We saw three special cases. Now the next one was, what if repetition is allowed, right? So if repetition is allowed, so arranging this would be n to the power of r. Is that clear, students? Okay. So there was another two concepts, but it will take some time, students. So we shall discuss those concepts in the next class. So just based on NPR what we have done, so we shall solve a problem. Okay. Example 10. I thought to complete that concept also, but due to shortage of time, so it requires time. Okay, so understanding of that concept requires some time. So tomorrow we shall start with that and start the work examples. Okay, so now based on the formulas we have done now, we shall solve a problem. Okay, example 10. It's in the page number 144, students. Example 10. How many four digit numbers can be formed? Okay, you might be thinking, sir, why sir is not solving example 9? So to solve example 9, we need one more understanding of the concept. Okay, I need to give you an exact explanation, okay, a background understanding before solving the example 9. Okay, so that we'll do tomorrow and start with the example 9. Okay, so now based on what we studied today, we shall solve example 10. So how many four-digit numbers can be formed by using the digits 1 to 9 if repetition of digits is not allowed. If repetition of digits is not allowed. Okay, so what is the question? Example 10. How many 4-digit numbers? How many 4-digit numbers can be formed using the digits? So which digits you have to use? From 1 to 9. If repetition of digits is not allowed, the condition is repetition of digits is not allowed. And which are those digits you have to take? The digits are 1 to 9 only. You have to take 1 to 9, that is 1 2 3 4 5 6 7 8 9. So using these digits you have to form a 4-digit number. So you might be saying, or you might be recalling that, sir, in while studying fundamental principle of counting also we solve some problems, so using that also we can solve, right? So that's why in derivation, while filling the boxes, npr we were solving. So npr we were solving, right? So to filling this first box and second box and third box, I was telling you, and means multiplication rule, right? So npr is same as multiplication rule only. Okay, so using now we shall see how we use the formula, or this we have understood in the multiplication principle also, right? So multiplication principle and npr both are one and the same. Okay, but we need to formulate, we need a formula, so we derived it. Okay, so now look here, how many total digits are there and are there distinct objects? All the digits are different. So total number of digits is equal to 9. And what are those? 1 2 3 4 5 6 7 8 9. If you observe, all are different, distinct objects. Why I am stressing, tomorrow you will understand. Okay, because we will study what if distinct objects are not there. So till now we studied distinct objects, all are different. Distinct means all are different. So we shall study tomorrow what happens if same occurs. That's what the example 9 is. So that means what happens if such type occurs. So here 3 are of same, 2 and 1. Okay, so we shall study tomorrow. Let's not discuss this. Again, we'll get confused. Leave this. Okay, so how many total digits are there? 9. Okay, so out of this 9 digits, using 9 digits, we have to arrange or form how many digits? So we have to arrange or form 4-digit number. Right. So its the arrangement is 9p4. You have to form a 4-digit number out of 9 digits given. So this is nothing but use formula. So what is the formula? NPR is equal to n factorial by n minus r factorial, students. Right. So this will be n factorial by n minus r, right? N minus r. So 9 minus 4. 9 minus 4 factorial, right, students, which is equal to 9 factorial by 9 minus 4, how much? 5 factorial, right? So 9 factorial, can I write it as 9 into 8 into 7 into 6 into 5, 4, 3, 2, 1. So while solving, I have told you, keep looking at the question carefully. In the denominator, we have 5 factorial. So I'll stop here itself. 5 factorial divided by 5 factorial. Right? You can simplify. You can split this and you can split this and cancel also. Doesn't matter. So this get cancels. Right, students? So 9 into 8, 7 into 6. So 9 8s are 72, 7 6s are 42. So it will be 303024. Right. So the total number of 4-digit numbers that can be formed out of the digits 1 to 9 when digits when repetition is not allowed is 3024. Okay, so I think it's not visible over there. So we simplified it 9876, which is equal to 3024. Okay, students, and we shall wind up today's class here itself. Okay, tomorrow we shall come across few more concepts. Thank you, students.
So, very good morning, students. So, before understanding about three special cases, you must know the definition of permutation. So, as we know that out of n distinct objects, right? If you are arranging r number of objects, right? Right? If you are if we have n distinct objects, if you are arranging r number of objects, then it is denoted as NPR as we know, and it is given as n factorial divided by n minus r factorial. This is the definition of arranging r number of objects from n distinct objects. This is the thing you have to remember. And what are the three special cases? The first case, so what will be the np0? Second one, what will be the np1 value? And third one, npn. So these are the three special cases. What do you mean by these things here? So out of n distinct objects, so how do you arrange? Nothing there, right? So if you are not going to arrange anything from n distinct objects, what will be the thing? And if you wish to arrange only one object from n distinct objects, what will be the thing here? And similarly, if you are arranging all number of all n distinct objects, what will be the thing here? So these are the three special cases. So we are finding the values of these things with the help of this formula definition. So now, similarly, in place of n, what we have here? N itself, in place of r arrangements is 0 here. Just substitute here. That what happens now? N factorial divided by n minus, instead of n we have n, and instead of r what we have? Instead of r we have 0. That's all. Simply just we have to substitute here. What happens now? N factorial numerator as it is, n minus 0 is n. Again it is factorial here. Just cancel it. What do you get? 1. So you have to remember this value. np0 is what here? 1. Similarly, same thing. Just go on substituting n as n and r as 1 here in this formula. So what happens? N factorial divided by n minus r is what now? Instead of r, what we have? 1. So just substitute r as 1 now. What happens? N factorial divided by n minus 1 factorial. As you know that 5 factorial is written as 5 into 4 into 3 into 2 into 1. So, or else I can express it as 5 into 4 factorial. Yes or no? So, you know this basic. In this basic thing, we express n as n into n minus 1 factorial. As 5 factorial is written as 5 into 4, same thing, n is written as what here? N into n minus 1 factorial. 5 minus 1 is 4 in that way. So, divide by n minus 1 factorial. So, according to the denominator, I will be splitting the numerator there. Got it? So, just cancel it. What do you get? N. So, np1 is what here? np1 is n. Similarly, same thing. You are arranging all n distinct objects from out of n distinct objects there, npn. So, substitute in the formula here, n factorial divided by n minus. Again, in the r place, what we have? N. So, in r place, I should substitute n there. So what happens? N factorial divided by what is n minus n? It is 0. So as we know that 0 factorial is what? 0 factorial is 1, right? So n factorial divided by 1 is n factorial. So these are the special cases and you have to remember it. Why? Because in dealing with the problems, you have to substitute the values directly there. Okay? So remember np0 is 1, npn is n. Sorry, np1 is n, npn is n factorial. So these are the three special cases by the definition. These are the special cases which is without repetition here, right? So these special cases are defined for without repetition. This is the formula without repetition. This is the permutation formula without repetition. Right? Repetition is not allowed. This is the formula we have to use. So what if repetition is allowed? So it is given as npr is equal to n to the power r. So this is what here with repetition. With repetition. Right? Got it? So npr formula is n factorial divided by n minus r factorial when you have to use this without repetition. With repetition means what here npr is n to the power r. Got it? So for these things, no special cases. Just only for without repetition we have like this. Got it?
Okay, one of the student is asking us to write 8 into 9 into 8 into 9 into 10 into 11 into 12 in factorial notation. It's very nice. See, what is factorial? Factorial is the product of n natural numbers. Suppose if I take here 1 into 2 into 3 into 4 into up to 10, it can be written as 10 factorial. Suppose if the number start from some other number, instead of starting from 1, they are starting from some other number like 8, 9 into 10 into 11 into 12. How can we write this in factorial notation? It is very simple. It can be written as 12 factorial divided by 7 factorial. 12 factorial divided by 7 factorial. How? See, this can be written as 1 into 2 into 3 into 4 into 5 into 6 into 7 into 8 into 9 into 10 into 11 and into 12. We want only this result, and this is extra, right? This is extra. Divide by same value, that is 1 into 2 into 3 into 4 into 5 into 6 into 7. And what is this? It is product of 12 natural numbers. This product of 12 natural numbers in the numerator can be written as 12 factorial and divided by product of 7 natural numbers. It is nothing but 7 factorial. Therefore, 8 into 9 into 10 into 11 into 12 can be directly written as 12 factorial by 7 factorial. If not, you can understand by this way by writing 1 into 2 into 3 into up to 7 in the numerator and divided by 1 into 2 into 3 into up to 7 in the denominator. The value is going to be 12 factorial divided by 7 factorial. Right? Thank you.